So now let's talk about displacement. Now for this we need to take an example. Let's take the example of a simple pendulum. Now we see that this is making an angle of theta. Now provided theta is very small, this will only execute simple harmonic motion when theta is very small. Very small. Now we will get to that part in the later half of our video. But right now, say this pendulum of mass m is slightly displaced and then it is left. That is, it is making an angle of theta. So we will see that there is a to and fro motion of this pendulum. Now we have classified that what is oscillation or what are vibrations. We have classified this as a to and fro motion. To and fro motion. Okay. So there's an interesting thing that we can derive from this particular definition, and that is all the functions which has a to and fro nature, all the functions which has a to and fro nature can be used to describe oscillation. At least some of the oscillations can be described by using the functions which has a to and fro motion, or that is sinusoidal functions. Now what is sinusoidal? That moves up and back with a common time period, that is a unique time period which is true for all its motion. So this is known as sinusoidal. So now by this particular statement and by this particular statement we will have an idea as that if a to and fro motion, if we have a to and fro motion or a oscillatory motion, then we can express this as a function of time. This is as a function of time. So that is, with relation with time there will be change in the position. Now the statement which I have given was with respect to time there will be in case of position you can easily say this to be displacement. Now why did we say displacement? Because this is its mean position. Now from its mean position, how much is this deviated or how much is this displaced? Therefore with respect to time there will be displacement. Now let me explain this to you. Say suppose at time t equals to 0, or say suppose at 1 p.m. you have the pendulum to be over here. Now it is said that this is oscillatory, that is it will move to and fro. So at 1:05 minute, that is 1 p.m., 1.05 p.m., you have a displacement of over here. Then again at 1.10 p.m. the ball again comes back over here. Then again at 1.15 p.m. the ball moves back to its left hand side, that is the ball is displaced. Again at 1.20 p.m. the ball again comes back to its equilibrium position from where we have started the count, that is we have started from 1 p.m. and it has returned at 1.20 p.m. So just by looking at this we know that the time period is 20 minutes to come back to its original position. Now please keep in mind, the ball once goes over here and then comes back. That is not its time period, because this ball was supposed to go this, it was starting to go this. So when the ball completes a complete cycle and comes back to its initial position and again will trace the same movement, please listen to this, again will trace the same movement. So it is tracing the same movement as it was done some time ago. That time is known as time period. And for this particular case, it's t equals to 20 minutes. So what happens? How much is the body displaced at t equals to 1.05 pm? What was the displacement? So the body is over here. So there is a displacement of x. So this is what is known as displacement. And all the if all the oscillatory motion, if there is a small displacement, all oscillatory motion can be defined or can be expressed as a function of time. Oscillatory motions, to or fro motions, can be expressed as a function of time. That is what we have established. And if it's a oscillatory motion, we can express this as a sine or cosine function. Sine or cosine. Now you will ask me why. The question should be why sine or cosine functions. The answer to this is because the nature of sine and cosine function is that, look at this particular diagram. This is y-axis and this is x-axis. So the sine function is a periodic function that repeats itself for after a fixed interval of time. As you know, sine 0 degree is 0, sine 90 degree is 1, sine 180 degree is 0, sine 270 degree is -1, and sine 360 degree is again 0. So from 0 to sine 360 degree, again if we go back, again if we proceed further, sine 360 degree plus 90 degree. So sine 360 degree plus 90 degree, this is actually equal to 450 degree is equal to again 1. So it will again follow this procedure. So it is repeating after a time interval of twice pi. So that is why sine and cosine functions can be used to represent a oscillatory motion. So from all of these definitions, our displacement can be expressed as f of t is equal to a. What is a? The displacement, the magnitude. For sine, the magnitude was +1. The extreme value that it can take, that for an oscillatory motion will depend. So we don't know, we have taken a variable a, and depending upon our oscillation we can set the value of a. So function related with t is equal to a cos of omega t, where t equals to twice pi by omega is a time period, and omega is the angular frequency. So we will define omega in our next video, but for now we have put a particular function to define oscillatory motion.